your technology, it's all about the Z factor. So in this webinar, we are focusing on the kind of the 3D aspects of data and how that you can use that within your business, within the tools that you have. This is the second of the webinars that we've been put out. There's a previous one to this one, which you may also find interesting, that you can go and look on YouTube. So a little bit about Abley before we get into it. I'm not going to do a massive sales pitch here. We'll just talk a little bit about Abley and then get straight down to it. So for those who work in the spatial industry, you probably will be aware of Interpret Geospatial Solutions, who were part of the then Abley Transportation Consultants Group. About 2 years ago now, we merged Interpret and Abley to create this new brand, or Abley Transportation Consultants to create this new brand, Abley. And Abley really is a mix of location technology and transportation. That's our happy place. That's what we really enjoy doing, working with Esri technology and working with transportation clients. But over time, the skills that we have and demands from other clients means that we actually work with quite a range of different clients in this space. Our head office is in Christchurch. We're also in Auckland, in Tauranga, Hamilton, Nelson and Napier, so we're spread all over the country. Just a little bit more about the location technology side of the business. So that's split into 3 main areas. We have location solutions, and we're really focused on using the Esri technology. So ArcGIS Online, Portal, desktop, building web apps and so forth. We also understand security, architecture really well. Most of our staff are certified. And of course, we're able to provide ongoing enterprise support as well. On the digital engineering front, we have FME certified professionals and server experts. We love playing around with AutoCAD, InfraWorks, BIM and 3D and seeing how those things gel together. And we're particularly proud of the work we do with LiDAR and point cloud information. And then just to round it off, we also have software development team. We've got 10 developers who focus on things like .NET, JavaScript, and so forth. And you'll hear later today a presentation from Subodh, one of our developers. All of our developers focus on geospatial, so they are experts in their own right within that area. And then just along the bottom there, we've got some of the clients that we work with. So agenda, I'm going to start off talking about augmented reality. We're then moving on to Vince, who's going to be talking about 2D and 3D data optimization and really how to maintain data well within your database. Jeremy, as ever, is talking about ArcGIS server security and how important that is. We then move on to Rob, who's looking at 2D and 3D visualization. And then finally, Subodh's going to talk about the Solitude application. This is something we developed for a hackathon, and it's been really good to see how well that's been received. Throughout the presentation, if you have any questions, feel free to put those into the chat window and we'll answer those at the end. Okay, so I'm going to kick this off and I'm going to start talking about basically augmented reality and how that can be used in today's business. So firstly, augmented reality, virtual reality, there's lots of kind of different terms, but I'm really focusing on augmented reality. And within the augmented reality area, there are 3 main types of augmented reality. So there's the flyover, and this is looking at a large area and being able to interact with it. There's the tabletop, and this is being able to look at basically you have a smaller area and you anchor it to something within the real world, the physical environment. Often the table, but it works pretty well with the carpet and other things as well. And then finally, there's this thing called world scale, and this is what you're starting to see from the likes of Google and maybe Apple in terms of how do you represent things on the world scale. Here, the little picture is being able to navigate more effectively. I'm sure many people have looked at Google Maps in a 2D view and been a little bit confused about actually where you should go. Well, augmented reality in this world scale is around trying to change that. From a geospatial context, what I found this little phrase is quite useful. So in AR, the real world rather than your base map provides context for your GIS data, and that's just a nice little way of remembering how you can use AR and how it kind of reflects the work that we do in the GIS space. So briefly, I'm just going to run through a bit of history about augmented reality and where it's come from. So, modern times we may think about augmented reality and the advances that it's made, but actually it goes back a good 30 years. And back in 1968, Ivan Sutherland, he was a Harvard professor. He came up with this kind of head-mounted display that allowed people to augment the world around them with computer-based information. And from that, you actually saw a lot of updates, particularly in the military, so head-up displays in fighter jets and so forth. One of the next major kind of updates was really in 2000, where the AR toolkit was released. This was an open source software package for augmented reality, and it enabled lots of other people to come along and take what that toolkit provided and started building apps on top of it. So 2000 was a pretty big step forward. Many of you out there will remember Google Glass. That was Google's step into this realm, and it provided kind of an augmented, immersive reality that people could make use of. And then, of course, Google kind of backed a little away from that, and then in 2016 Microsoft developed the HoloLens, and I think they've just released the HoloLens 2, and this kind of really takes the idea of what Google had done in Google Glass and moved it a lot further forward. More recently, augmented reality has become really popular. So I'm sure everybody remembers Pokemon Go and how everybody was running around with their phones trying to find little Pokemon, and even simple things like Snapchat, being able to put ears, a nose, and a tongue on your face. That's another example of augmented reality. So it's become much more prevalent in current times. Now, one of the things about augmented reality is that device position and the data that you're trying to visualize is really key. It's about understanding exactly where the thing that you're looking at actually is. Now, that's been a problem in the past because your GPS chips in your phone in particular haven't been that accurate. But more recently, the Broadcom company who produces lots of mobile phone chips have released the VCM47755, which is a dual band high precision sub-meter-ish GPS chip, and these are starting to appear in current mobile phones, and that gives you much more accurate data. What you're also seeing is their new integrated systems. So, for example, the Trimble Sight Vision, you can see a picture of it here, but basically you plug that into your mobile phone, and then the Trimble GPS accurately GPS overwrites your GPS chip, or overwrites the GPS feed into your chip, and that gives you much more accurate location information. AR and GIS actually seems like a really natural fit. If you actually think about it, everything you see in AR relies on spatial data in the background to make it work and make it work well. So we're seeing a growth in kind of taking BIM, CAD, and combining that with GIS data to put that into an AR space. That's particularly powerful for digital engineering. So understanding, where pipes, where other engineering type information and how that interacts with the real world. We're seeing it in construction, so understanding what will this building look like once it's been completed, as well as in architecture. So actually giving planners a far better understanding in the real world of what a particular development will look like, maybe over quite a large scale. Various companies have been trying to exploit these areas over the years, and actually we can go back into 2011 and Esri started to look at how augmented reality could be used, and since then we've seen major advances. So ArcGIS, you may have heard of that. This was a New Zealand company who who created one of the first or the early augmented reality apps that allowed you to understand where pipes were under the ground and other things as well. Moving on, we've got ArcGIS out of the States. This is kind of, again, moving forward each time. We had Esri. You can go to the Esri labs and you can download AuGeo, which is an Esri apps augmented reality app on your phone that you can push your data into, and then we look at something like VGIS, which is really current, and you can see the kind of information that they're pulling out and the nice interface that they have here. So it's really grown from strength to strength over the years. As mentioned at the start, we are also FME professionals, and FME has also got involved in this space. And there's the FME Augmented Reality Translator that enables you to take data and push it into an augmented reality space. They have an app which you can go and download. It's both for Android and iOS, and you download that. You grab an OBJ or other data. In this case, the example I'm going to show you, we got some mesh data from Aerometrics. We ran it through the very simple workbench. You can see here it's really simple, and what you end up with is quite a nice example of how you can quickly build an AR app. So in this case, we're looking at Ports of Auckland, looking at their data, and you can see how, firstly, how large an area is that you can look at, and secondly, how easy it is to actually build this up. So this was just a simple workspace, pushing the data onto your app, onto your phone, and then opening the app and viewing the data. So where will we be tomorrow? What's happening in this space? Well, firstly, big players are really engaged in this space. So Google is embracing AR, and the more you look into Google, the more you understand how important it is to their entire ecosystem. So it's not just about navigation. Some of their searches will then create 3D models that you can then interact with. Big step forward is Apple's new iPad Pro has a LiDAR scanner in the back of it. That's going to be amazing for AR, and in fact, the reason Apple put the LiDAR scanner in there was really to enable AR to work better. Various reports have been looking at the AR market, and they believe it's worth somewhere between 70 to 75 billion by 2023. So that's an awful lot of value in the market, and actually the value in the AR market outweighs the value that's seen in the VR market. So things are becoming, or the location of things are becoming more and more important, and we kind of recognize this as spatial practitioners, and AR is going to become more important. So working and understanding more about in this space is really important for many people in this industry. And as I kind of shown, it doesn't actually need to be that difficult. If you have access to FME, if you have access to Esri Kit, then you can start getting involved with this already and start moving things forward and trying the technology. And it's well worth you doing it. It's surprisingly easy to do, and you quickly start to see the value from building these models. So where are we going? Here's just a final example of what you can do. So this is using VGIS. And we're going from reality to what's going on underground the surface, and you get this kind of really good interaction between reality and what you actually want to see going on underground. Every time I see this, I'm blown away by how good it is. Okay, so that's enough for me. I'm going to move you on to Vince, who's going to talk a little bit more about that data and how you can use and how it can be optimized in the background.
Hello, I'm Vince Poi. I'm the database administrator at Abley, and I'm just going to talk about some technical tips and tips and tricks and optimization things you can do with your 2D and 3D data. So I'm going to break this down. I'm going to talk firstly to 2D data in your geodatabase. 3D surface data, and 3D feature data. So with 2D data in a geodatabase, you can just run your regular maintenance tasks such as analyze and rebuild index, compress. Pay particular attention to compress. We want to make sure we want to do a full compress. I've seen in many implementations where, particularly if you're serving your data through a feature service with sync capability enabled, you can sometimes inadvertently create replicas or versions in your database, which will slow down the delivery of that data. So just to be aware of that. And also archiving, which is great functionality in the geodatabase. Just make sure you don't keep the history for too long. That will slow you down as well. Also generalize the geometry to fit for purpose. I was in a transportation project recently where I had a data set with boundaries and it had a very detailed coastal line. Of course, we don't need coastlines down to centimetre accuracy for a roading project. So I simply just generalized that data, which sped up delivery considerably. So the idea really is to efficiently store your data for what you need it for. And then you have your 3 geodatabase types: file, enterprise, and also in a relational database management system such as SQL Server, Oracle, or Postgres. All of those can serve spatial data. So a database that's not registered with the geodatabase is still able to be edited through a feature service, and that's becoming more common. The word is still out whether it is faster or slower. Yeah, it really depends on how you've implemented it, and also the type of data and how you use the data really comes down to that. So the general rule is you use an enterprise geodatabase if you really do need a multi-user editing environment, particularly with desktop or pro. Otherwise, you're probably better off just using a file geodatabase or not registering with a geodatabase in an enterprise database such as SQL Server. Moving on to 3D surface data, you've got tools such as analyze and compress. Setting up your pyramid is particularly important, particularly when you are generating a DSM or DEM from a LAS data set. There are lots of options there. Managed and unmanaged data in a geodatabase. Managed is generally faster because it is stored within the geodatabase. It's pre-processed data, whereas unmanaged is sourcing data outside of a geodatabase, such as tiles. Unmanaged is great because it's flexible when you add new data. But it is generally slower depending on how it's set up. And it's often a good idea for unmanaged data. It's often a good idea to store your original data sets in a organized folder structure, so the directories are ordered in an orderly manner, so it can be easily shared. Now, reducing data density, you're probably wondering what that is. That's a similar concept where in 2D data we've generalized to generalize the data so the output is more efficient. Because the idea is we want to reduce the amount of network traffic in the network between the geodatabase and whatever client is consuming it. So if we can set up our 3D data so that the output is more efficient, generally that will run faster. So things you can do is you can avoid things like reprojection. You can avoid pyramid resampling, which is things like setting up either nearest neighbor or cubic so it matches where it's going to be served. And it runs along the same lines as reducing system processing. So that's things like reprojecting on the fly. So if your source data is in MapGrid and you have base maps, or you're trying to serve out in NZTM, that is going to hit the server processing, and it's going to create quite a lot of load and reduce performance. So we want to avoid that where we can. And also generally, we want to use file geodatabase. There's very little need to have it in an enterprise geodatabase, even though the functionality is effectively the same. And moving on to 3D feature data, I've put file geodatabase right at the top because that's what you should be using as a geodatabase choice. And the reason for that is, so the last bullet point I've mentioned, there's a, in an enterprise geodatabase, if you start creating 3D feature data, such as multi-patch data, it will create this field in the database to be able to handle and to be able to store those types of features, 3D features. Coincidentally, it also stores 2D curved data. But what this field does, it stores it, but it's not very efficient. So there's no way you can index this field. It's basically a workaround from the native database spatial data type. So if you use a file geodatabase, it doesn't use this extra field, so it delivers the data more efficiently. And you can use tools such as Analyze and Rebuild Index, Compress to optimize the geodatabase whenever new data is brought into your 3D data set. And yeah, that's all I wanted to cover today. So I'll move on to Jeremy Clark.
Cool. Good afternoon. Obviously, I'm Jeremy Clark. So I am one of the solution architects at Abley, and today I'm actually slightly misleading title. I'm going to talk about WebGIS security. So not just ArcGIS Server, but all the components of your ArcGIS enterprise. So things you need to think about to keep your system secure. Let me find my mouse. So a lot of us think about security and we think about our systems and we think about ArcGIS Server and Portal and all that kind of things, but you actually really need to be starting your thinking way back at the data level. So really start with your requirements. Do you really need editing? Is that the requirement for your system, or is it a public app? How do you secure it? How do you keep it from people editing things they shouldn't, and things like that? So that's really where we should be starting. One of the problems we've seen with clients recently is people starting out creating an editable service and then putting stuff into that editable service that they really shouldn't need. So it's also looking at your data design and going, okay, I've got a field where I need to put an address in. Should I be putting a plain text that people can just type something, whatever they like in, and run the risk of entering content into that they don't really want to be showing? We had a case where security testing came up with issues that a customer could basically, or a user of a system could inject scriptable code into that field, because it's just text, you can put anything in it. And if you're executing it in the wrong way, that would obviously cause issues. So things like domains is also another area you might want to be thinking about. So yes, you've got a field, you need to have a drop down, let's say for land type. You want to make sure that you're, rather than just going, hey, you can type in the land type, one, for a data cleanliness perspective, it's good to use a drop down, but two, it also stops anyone from putting anything into that system that you don't want. So an integer domain, much safer, much more sensible than having the ability to put a 2000 length string into it and put anything you like into there. Another area you may want to be thinking about if you are going down that secured application route is what kind of security do you need? Are you going to be using AD? Are you going to be just using your portal named users? Do you need your integrated windows? And And also, do you need that multi-factor authentication over the top? So a client we worked with recently, they realized late in the project that they were originally thinking about using named users, but they also wanted on-premise Esri. And so on-premise Esri at the moment doesn't support multi-factor. So in the end, we reverted back to an AD user, which was a better approach for them. So if you're using ArcGIS Online, you can configure it to consume a multi-factor, like a second authentication, but our on-premise system in the end used AD. Cool. So the other thing that you want to think about, and this is probably something most of us do think about pretty regularly, is for your WebGIS, what technology are you using to present it? So your maintainability is quite heavily tied back to what platform you choose. So if you go down that custom route, it's really important to consider right from the start, how are you going to maintain it? There's plenty of people out there who go and build a JavaScript map or even a web app builder with custom widgets, and it can be difficult to look right at the start and go, oh, yep, cool, implemented this, it's going to do me for 5 years. But when there becomes a security issue down the road, what's your strategy for maintaining that? So obviously, New Zealand, we've got quite a mix out there. So a lot of people are using Web App Builder. A lot of people and a lot of councils particularly are using local maps. There's a fair few of us still on Essentials, which was obviously popular a few years back. And lots of those productized offerings, they do have that natural road to upgrade in there when they release a new version and so on. I mean, I think Local Maps last I looked was at version 2.3. We'd expect that over time it's going to get upgraded, and GeoCortex I think is at version 4.13 if you're on Series 4, and version 5 is obviously out there as well, and Web App Builder and custom JavaScript apps are another option too. So yeah, it's really important to consider when you're choosing your platform or with your platform for WebGIS that you've already chosen, is to make sure that you're in a position where if 6 months down the line you need to upgrade it, you actually have that path for upgrade and your plan to maintain it. You don't want to be in a situation where you're sitting there on an old out of support version of Web App Builder, for example, and you're stuck there because of a certain widget that you've built. Along with your apps, though, the other thing you need to think about is not just your front-end version, but also your back-end version. So a really good example of that recently, we were working with a client who has a custom Web App Builder-based application, and it used Node.js in the background. So very cool, pretty common component. But it was using Node.js version 6, which, if I recall correctly, was out of support quite some time ago, maybe 6-12 months ago. And that's actually a real risk with some of those supporting APIs and those supporting SDKs, is you develop upon it, but at some point you're probably not aware of what's inside the system and what dependencies you have. And so yeah, this Node.js version was out of support, and in fact Node.js is, a lot of them are. So I think that was version 6. I think the current minimum supported version is 10 or 12. So it's really important to look at what you're using inside your applications and inside your WebGIS and what components you actually depend on. A lot of systems are depending on things like .NET, ArcObjects, Python, the Esri JavaScript APIs, and there's always a risk of building this lovely app and then finding out 2 years down the road, 6 months down the road, that the things you depended on are no longer supported and are at risk of being deprecated and your app no longer working. So keep in mind, you've got your web app, that's really obvious and really important to keep up to speed. Your ArcGIS Enterprise is really important to keep up to speed, but also keep in mind all those underlying components in your system. So don't just think about Esri, think about your .NET, your Node.js, your Python, and all those other components that make your WebGIS spin. And of course, over top of it all, just remember, so 10.4, it's now out of support. So it's in mature support. So you won't be getting any updates or patches for that anymore. So if you are running 10.4 or earlier, it might be time to consider upgrading. So yeah, that's a quick rundown of support from me and security, and we'll hand over to Rob, who is going to be talking about 3D, which is always exciting.
Thank you, Jeremy. Hi, everyone. I'm Rob Pointer. I'm talking about 2D to 3D visualization and some of the fun that I've had recently. So I thought I'd just briefly cover some of the past challenges that we face with. Anyone familiar with GIS would know that 2D's jumped along quite quickly. 3D has in the past been quite glacial. It's only really starting to pick up now. I'm sure you're all familiar when you've tried to make a web scene in the past that it can be pretty ugly, quite slow and clunky and unresponsive sometimes, and you can't really share or collaborate with other people too much, but that's sort of starting to really swiftly change. So I've been using InfoWorks recently from Autodesk, and out of all the Autodesk platforms that are available, InfoWorks I found is the easiest for a GIS person because it's all fairly familiar. You've got a web view, map view, sorry, and you've got a ribbon at the top to do various things, and you've got a table of contents, and it can just bring in and various different data types. So we call this infogration, where we have an Esri data source. It could be local, it could be on the AGOL, and we just bring it in and we match up attributes in it with InfoWorks style rules. So we can see here we've set various attributes, and that automatically gets fed through and updated to make a contextual 3D model in InfoWorks. So a little bit more on that. Here we've set different road types and classifications. It just takes these from the attributes and feeds them in, and it says, okay, where description equals motorway, we'll make it the style, and you can make it more complex and configurable than this. And here's a quick video to show that you can draw something quite simple in 2D, bring it into InfoWorks, and if it's configured already, you can make a bridge, you can draw a building, add a car park, bring that in, automatically comes up displayed. You can do this from different angles to see the effect. You could look at how your development might appear from different angles, and it just adds a little bit more conceptual information. Obviously you have to set up these style rules in advance, but here we can bring in a house with a wall around it and trees, and then if we set these style rules, we can change the trees to appear differently. We can rotate things, so people can be using Collector or a custom made web app, and they can be doing these changes in 2D, and it can be fed through immediately into InfoWorks, and it's really quite simple. You're only dealing with simple geometries, but the effect can be quite interesting and quite quick, how you can make these different scenes. And you can also do fly-throughs as well. So you can just have a look at, maybe this is how a road does look now, but you can optimize it and you can think, okay, we want to do this, we want to change these plans, put some cycle lanes in. And you can do fly-throughs to focus the attention on different things and just show a wider breadth of information. There's Abbey Road there. You can throw little things in like that. There's heaps of different configurable 3D models and things. It's all a little bit US centric, but if you play around a little bit, you can make things look more New Zealand. You can do underground as well. Oh, sorry. And there's other options as well. So this is Twin Motion. It's a little step above InfoWorks. You can add different real world views, weather, rain, and things like that. And it's just adds even more reality into your models. You can do fly-throughs like this. I guess the question does come back to, is this adding real value? You know, you can spend ages making these really nice realistic models, but I guess it always comes back to, what are you trying to convey what does the client want, and so there's powerful things that you can do, but yeah, you've always got to have that in mind. What are they after, and what's the best way of conveying that? And the future, there's been a lot of talk recently about sort of gaming technology and GIS merging, Unreal technology. This is a scene that was initially built in City Engine, Esri's City Engine, and then it's been enhanced quite a lot by Unreal technology, and it's quite impressive, the level of detail that we're seeing now. So it's a really exciting space to be in. It's not my usual bread and butter here at Abley. This is sort of more of my fun time, bit of dabbling, but it's really interesting to think how we can apply these new technologies to our clients' needs. Yeah, so that's all me. We'll head over now to Subodh from Software Dev.
So I am Subodh Jangwal, and I work in the software development team here at Abley. And I am here to talk about the Solitude app, which we developed during the COVID-19 lockdown, which was part of a hackathon which we did. So Solitude, staying social, basically. So what is actually Solitude? Solitude is an application which help user make intelligent social distancing decisions by providing some sort of busyness information about a point of interest in your nearby place. Easy, for example, like how many people are in a particular shopping mall or in a cafe. So it brings that information to the user so that they can make a good decision on whether they want to go in there or not. A real use case after I've created it, and I was going to a Pack and Save supermarket with my wife, and it was chock-a-block with 50 people on the line, and my wife asked me, "Why did you not check your app before?" I was speechless basically that time. So hackathon. So this is Solitude was developed part of a hackathon challenge, which was hosted by here, a location-based GIS company, geolocation company, I should rather say, and they hosted a hackathon during May with a pretty cool prize as well. And there were a couple of prerequisites for it. We must use the here location API. That was number one requirement, and the second one was the idea should be related to some sort of adding value to COVID-19 period, so mitigation or something. So this was a 3-week challenge for us, and we were number 1 in Oceania. And there were around 50 teams, 800 participants in the challenge. So that was a pretty cool result. So Solitude was developed because this is a public application, public facing application. So it was designed with a mobile first approach. So it works on any sort of device, iPhone, Android, or wherever. Whichever device you have, but designed specifically to cater for mobile, but also works on desktop mode with a different sort of layout. It automatically switches that. So it uses the here location API to bring the information about the point of interest, which you can see like in the slide here. It has a data integration with Uber Media, a company which provides data on some sort of how many people are there in a particular place. That data it provides generates using some IoT sensors, and we use that data as a proof of concept in this. We designed a smart busyness calculator based on that data, and with a score of 1 to 5, 5 being the highest, busiest. Right. So as I mentioned before, the deadline was very tight. So 3 weeks, and on top of that, this was we already had the development team already had the other mainstream projects. So this was taken as a secondary project, but very well received from the team first. Everyone was interested due to team bonding. We used Scrum and DevOps framework to deliver this project, because it is we normally use Scrum and DevOps anyway, but this was really because it was 3 weeks challenge. So Scrum and DevOps made it really deliverable in that tight schedule. Also, we use Azure DevOps as our framework to deliver to look at the entire life cycle of the project. I would want to give you a quick demo of the application here.
Hey, thanks, Abode. Yeah, apologies for the slight technical issues there. Occasionally it happens. Yeah, thanks to everybody who presented there. You know, I get to see this every day, but yeah, it's really good to see the kind of the work we're doing at the moment. So we've had a few questions as we've been going through, and I'll read these out and hopefully direct them through to the right person. So what have we got? So we have for security. Has anybody seen any security breaches in ArcGIS recently? I'm guessing that's for you, Jeremy.
Lucky me. So based on the updates we're getting from Esri, it's fairly, you don't hear of any security breaches specifically, but there has been some recent patches that have been released around service-side request forgery and stuff like that that suggest that there is still issues, particularly if you're running a system on Amazon. So the most recent ones were specifically directed at Amazon. Additionally, so with some of the projects we do, we undertake security testing and penetration testing, and some of that has come from those sessions. So completing pen testing and getting vulnerabilities highlighted in some of the Esri functionality. So things we've done, obviously kept our service patched is always a good activity, but also in some customers we've implemented things like SOIs and stuff like that to monitor what's going on and ensure that there's nothing dodgy getting in. So yeah, no specific cases, but there's definitely patches and stuff out there to address it before it becomes a problem.
Okay, cool. Thanks, Jeremy. Oh, a question from me. Hey, Chris, what's the elevator pitch for describing mixed reality, virtual reality, and augmented reality? Blimey. I think it depends partly on your business and what your particular business is trying to do. If I take ports an example, the elevator pitch there was, well, particularly during COVID, being able to see what was at the port without actually being at the port, so to speak. The project's moving on forward there, and we're just about to push in things like underground services, locations of other assets, and so forth. So really, it's about being able to understand what's there, particularly in places where it can be difficult to actually see the data itself. The kind of that dial before you dig, understanding what's underground is also a huge benefit of things like augmented reality. Okay, moving on. With compressed LiDAR files, should you leave LiDAR points in a compressed format or non-compressed when doing analysis? Oh, Vince?
Yeah, I would recommend leaving the LiDAR files in its compressed state. I've never actually tried uncompressing LiDAR files. Yes, I wouldn't be able to comment on its uncompressed form, but standard practice is to keep it in its compressed format. Yeah, I think there might be other members in our team who've played with LiDAR points recently. Speak up now.
I haven't played with them that recently, Vince, but same feedback. I'd just reinforce that with LiDAR, there's no good reason that I'm aware of to be using it outside of the original compressed form. So just leave it as your LAS files and work with it like that. It works perfectly fine.
Cool. Okay, thanks, gents. Another question here. This one's for you, Rob. InfraWorks looks cool. How much does it cost, and how much effort is it in InfraWorks to create a scene from Arc Pro? So 2 questions there. We should point out we're not resellers of InfraWorks, so that might be go and talk to your local InfraWorks reseller. But yeah, Rob.
Yeah, sure. Well, thanks for saying it looks cool. Glad that someone thought that. No, that's good. So from Autodesk, usually you would get things as a package, but by itself you can buy it for 3,000 NZ annually. So it's not too much compared to a lot of similar types of software. And that second part of the question, I suppose it depends on how big the scene is and how complicated it is. You can bring in all the data from an Arc Pro scene and configure it to be a 3D scene. You can make 3D models from the, say, building footprints or building models. Yeah, it just depends how much layering and detail you want to add to it. I think you can make far more sort of intricate and complex models, but to sort of match something that was made in Arc Pro fairly quickly, probably as fast as building it in Arc Pro or faster. Yeah.
Okay, cool. Another question here. I'll take this one. Is Uber Media data from Uber? Good question. No, it's not. I think the 2 companies just ended up with similar names, but interestingly enough, they are broadly based on the same type of data. So Uber Media, it takes mobile phone data from hundreds and hundreds of different sources. If you've ever used an app and it's asked to use your location, be aware that the chances are you're feeding your location back to somebody. And Uber Media is an organisation that works with a whole lot of app providers to take that data and provides it as another data source to other organisations. It's pretty good stuff. So it's well worth understanding what Uber Media can do. And if you have any interest in understanding about where people are and how people move, then yeah, certainly get in touch with us and we can help you with that. Just looking, are there any more questions? No, I think we are about done. So look, we're pretty much on time. Thank you for your time today, those people who have joined us. If there is anything you saw today and would like to know more, you can see the details of the people who spoke. So please just reach out to those and ask again if you don't want to ask in this kind of public forum. But yes, thank you very much for your time. Thank you to Vince, Jeremy, Rob, and Subodh, and the team in the background who have made this possible. Joel, Mel, and Mark. And yeah, thanks for your time. And hopefully you'll join us again when we do another webinar. Thank you.